Thank you very much for opportunity to share this research. I'm Hanna Halaburda from NYU Stern, and this is joint research with Yanis Bakos, also from NYU Stern. The huge interest in blockchain is closely related to the promise of smart contracts to change interactions and make the business landscape more decentralized and democratic. The concept of smart contracts themselves comes from earlier times than Bitcoin's blockchain, because it goes back to 1996 to Nick Szabo's definition of smart contracts, and the first example, the now most seminal example of a car lease, where a buyer of a car, upon missing, if the buyer of the car misses a payment on a car, then the smart contract automatically locks the car and transfers the control over the car to the bank. This automation of control transfer may change the relationship between the bank and the lenders. Now, the examples of how smart contracts can be implemented and how they can change the business relationship have multiplied over the past decade. And it has been said that the smart contracts will make contracting complete. They may allow us to get rid of courts because of the automation. They may allow us to get rid of costly escrow and other trusted enforcers. And they may enable complete decentralization, for example, through decentralized autonomous organizations. So there's a great promise in smart contracts. What we have set out to do is to analyze what are the benefits of smart contracts really. And for that, we built a model where we distinguish the benefits of smart contracts from other technologies. So a smart contract is basically a computer program where upon a trigger, it automatically executes an agreement between the two parties to the contract. And the key characteristic that we are going to draw upon is that it does not allow reneging because it is automated. So once the smart contract program is set in motion, then the parties cannot withdraw from it and they cannot change their actions. One of the most important limitation is that the trigger and the agreement in the definition of the smart contract needs to be well-defined, and they need to be digital because both the trigger and the execution of the smart contract is digital, so at least digitally controlled. So that means that not every agreement lends itself to smart contracting. We are going to focus on the ones that do lend themselves to smart contracting, but the fact that that smart contract needs this digital input is crucial to our analysis. Very often, the digital inputs come from sensors that only need to be installed. They are not readily available. So this is where the connected sensors or Internet of Things sensors come into play. And in many examples, in fact, in most prominent and most promising examples of application of smart contracts, there is the effect of smart contracts and the sensors have been confounded. So even in the example of the car lease that comes from Szabo, what we need for the smart contract to work is a sensor or an automaton in the contract that is going to control the control over the car. You can't just write a program without a connection to the car that would transfer the control rights to the bank. There needs to be a sensor to do that. So we recognize that the sensors and smart contracts are different things. There are different technologies. And we set out to, by building a simple model, to separate the effect of smart contracts and sensors to see which technology brings how much benefit in different situations and whether we need both of them or just one in different circumstances. What we realize is that sensors, when they are implemented, they expand the space, the state space, which means we can write more detailed contracts over many more variables, because now those variables are very visible and verifiable. Smart contracts restrict the strategy space. They restrict certain actions that the parties can take. Those have very different consequences on the efficiency of a contract. So we are going to use a simple model of a simple example of a fruit shipment. So we're going to have two firms, a fruit firm and a transportation firm, that contract over transportation of a perishable good, fruit. So fruit, if it's shipped in properly refrigerated conditions, brings a high value to the fruit company, but it also costs a lot to ship it in refrigerated conditions. When the fruit is not refrigerated when it's shipped, then it brings lower value to the fruit company, but the transportation company can do it at a lower cost. We assume that it brings higher value to refrigerate the fruit and ship the fruit refrigerated, so the difference between the value and the cost is larger than when the fruit is not refrigerated. But it is still worthwhile to trade and to ship the fruit even if it is not refrigerated. Now, what is important, what we are going to draw upon, is that the fruit company does not see immediately upon delivery of the fruit whether the fruit was refrigerated or not. It often turns out a couple of days later when the fruit goes bad on the shelves because before it was sold or needs to be sold at a discount, but it's not visible right away. When the fruit is not shipped, both parties obtain zero. This is a benchmark case. An important element of our model is that once they have an agreement, if something goes wrong and a dispute is brought to a court, then both parties have a cost of taking legal action. We are making simplifying assumptions here that the cost is going to be the same no matter who initiated the action, no matter who wins. And we're going to also assume, for simplicity of the argument right now, that the courts are always fair and they always have the ability to enforce the contract terms in full. The model can be modified to incorporate other modifications or other aspects, but we want to bring out the main idea of what is the difference between the smart contracts and sensors in this situation. So in this initial situation, before bringing any additional technology, smart contracts or sensors, the refrigeration is not observable to the firm company, nor is verifiable to court. Therefore, the contract cannot be written taking into account whether the fruit is refrigerated or not. What is visible and verifiable is whether a payment has been made and whether the fruit was delivered at all. So we are going to assume that there is already some information that is available, and we would need sensors to bring in more information. So the game in its extensive form is represented in this tree. So what we see is that the transportation company, upon assigning the contract, has a choice of providing low quality delivery, which is without refrigeration, high quality delivery with refrigeration, or no delivery. If the fruit is delivered, now the fruit company can pay according to the contract, or they can renege and not pay at all. If they do not pay, the transportation company can bring the case to court, and if it takes the case to court, then incurring the cost lambda. After incurring the cost lambda, the terms of the contract are enforced. So in this initial case, without any additional technology, what we see is that trading is never efficient. So one thing is that if the legal costs are really large, then there is no contracting. And this is because the transportation company, if it shipped the fruit and it did not receive the payment, will not find it worthwhile to go to the court, because the payment they are going to receive will be lower than the legal costs. If so, they are not going to go to court if they are not being paid, knowing that the fruit company is not going to pay upon delivery, and knowing that the transportation company is not going to deliver the fruit, and they are not going to sign the contract. And even when contracting is occurring, then if the legal costs are low enough that the contracting is occurring, because the fruit company cannot pay more for high quality delivery and less for low quality delivery, then the quality of delivery always will be low. Now, in this situation, if we add smart contracts, would hope that maybe smart contracts would solve the problem. And it turns out that they solve a problem, but only partially. So let's assume that we are adding smart contracts to the situation we already have. So a smart contract is going to automatically create payment from the fruit company to the transportation company upon delivery, because both delivery and the payment is verifiable. So now the fruit company no longer has a choice between pay or not pay upon delivery. So the game tree looks differently, because now these strategies are removed. And if these strategies are removed, now every time it is beneficial to trade, there will be trade. However, so we gained some space where the contracting is happening, and it would not have been happening before. Now, what does not happen if we just add smart contracts is the higher quality of delivery. There is no reason for the transportation company to provide a refrigerated delivery just because the payment is done automatically. So that there will be still only low quality delivery provided. Now, if we add sensors, but only sensors, without smart contracts, then the sensors may allow us to distinguish between refrigerated or not refrigerated shipment. So what we imagine here is a type of temperature sensors that are put in within a transportation package, or close to the fruit, or in the container, and they register the temperature, and they can show upon the delivery, or maybe even earlier, whether the temperature has exceeded the limits, the accepted bounds. And if it has not exceeded accepted bounds, then it is considered to be high quality delivery. And if it has exceeded, then it is a low quality delivery. With that, now we are able to write a contract that is going to pay different price if the delivery is high quality, and a different price if the delivered quality is low. With that, in equilibrium, we are going to get a high quality delivery when delivery occurs, because it is possible to write a contract that gives proper incentives. So this is a nice improvement. But just having smart contracts is not taking away the problem that if the price that the transportation company is going to receive for high quality delivery is exceeding the legal costs, then again, the transportation company is not going to seek legal action if it's not being paid. Therefore, fruit company is not going to pay, and therefore, transportation company does not want to sign a contract in the first place. So while the sensors are increasing the quality of delivery, they are not improving on the region where contracting is not happening because legal costs are too high. So they make trade efficient when the trade occurs. Now, if we add both the smart contracts and the sensors, then we can write a more detailed contract that is distinguishing between the refrigerated and unrefrigerated delivery. And at the same time, we can eliminate the possibility of fruit company reneging and not paying, because now the payment can happen automatically upon the reading of the sensors. With that, we are achieving efficient trade for all parameter regions. So while each of the technologies could not fully achieve this efficiency for any parameter set, then together they can achieve this efficiency. So there's complementarity. So what we have shown with this simple game is that the fact that smart contracts and sensors affect the interactions in the contracting differently, they have different effects on the outcome of the contracting and whether the contract is signed in the first place. So sensors increase the state space over which the parties can contract because they give more information. And smart contracts reduce the strategy space. They eliminate certain actions that the parties can take. So they can be, what is important is that they can be implemented separately. They don't have to be implemented together. And implementing each of those technologies bring different benefits. And of course, they have separate costs. So what we are seeing from this summary table here is that smart contracts, when we implement smart contracts, we are extending the possibility, we're extending situations in which the contract is signed at all. But if we add sensors, then we are going to improve the quality of the service when the contracting happens. So those two technologies have different results, different effects on contracting. Now, with that, we actually can say more about whether it is beneficial to adopt one of the technologies, the other technology, or both of them together. And it may not always be best to implement both, and may not always be beneficial to implement smart contracts or to implement the sensors. So what is beneficial depends on the cost of implementing smart contracts, cost of implementing the sensors, and the legal costs. The legal costs are the driving force here, because this is where smart contracts are, the automatic execution in smart contracts is playing a big role. So what we find is that under some conditions, adding second technology brings no benefit. When we have smart contracts, then Internet of Things is not adding anything. And if we have sensors, then smart contracts are not adding anything. And in other times, it is beneficial to implement one technology only if it makes sense to implement both. So one of them in itself is not adding benefit, only together. So it is important to see under what conditions we get different results. So first of all, if the legal costs are relatively low, are actually medium in this graph, if the legal costs are very low, it never makes sense to implement smart contracts if the smart contracts are costly to implement, because they do not bring additional efficiency in contracting. However, if the smart contracts are medium, between, then it make sense to implement smart contracts, but only without the sensors. Whereas for region, when it makes sense to implement the sensors, then adding smart contracts is not adding any more value. So bearing the cost of adding smart contracts would actually be detrimental to the surplus, because it would be bearing the cost without any additional value to the trade. Whereas if we have large cost of legal action, then there are regions when it makes sense to implement smart contracts only. But if implementing sensors is not too costly, then it makes sense to implement sensors, but only if we can do it together with smart contracts. Only if it makes sense to bear the cost of implementing both technologies together. For large legal costs, implementing just sensors is actually not adding any value. It's not improving the trade. So this is for social efficiency. This is when it would be best for the trading benefit, overall trading benefit, to implement one or both technologies. But it may be different than the individual incentives to adopt. So while the surplus created by implementing these technologies can be divided between the two parties, how the surplus is divided depends on their bargaining power, relative bargaining power. So now it turns out that in some cases, like for example, for smart contracts, when the transportation company has low bargaining power and we have low legal costs, the fruit company will have incentive to impose smart contracts, which are not necessary. They would bring no overall benefit to the trade surplus. There would be an additional cost of implementing smart contracts. But by implementing smart contracts, the fruit company can extract more surplus from the transportation company. So they will have incentives to go for a socially less efficient action, and in fact to implement more technology than is socially optimal. And also, if transportation cost has low bargaining power, they may be worse off with implementation of sensors. So it will increase the overall social surplus, but it will decrease the price or the price versus the quality of the service provided that the surplus that the transportation company gets. And if we account for the fact that the individual incentives to adopt may go contrary to the social incentives, especially in the context of sensors, we may understand the incentives to sabotage sensors if they are implemented, even though sabotaging sensors could destroy the social surplus. So the last point is actually the subject of our next project. And to summarize this project, we have right here, we have built a model to carefully separate the effects of smart contracts and connected sensors. We recognize that sensors increase the state space over which we can contract, and smart contracts reduce the strategy space, so the actions that the parties can take. And with that, they have different effects on the efficiency of the contract. And as they have different effect on the efficiency of the contracting, and they have different costs of implementation, we derive conditions where it is socially optimal to adopt one of the technologies or both of them together. And later, we also analyze the incentives to adopt, and we show that even though the technologies may be socially optimal to adopt, there may be one party that will either oppose or will lose on the implementation of the technology, which may lead to sabotaging it. So with that, let me thank you, and I look forward to the Q&A. Thank you very much.